The talent code explores the idea that extraordinary skills aren't just the result of innate talent, but rather the product of deep, focused practice. At the heart of this concept is deep practice, which involves breaking down complex skills into manageable parts, practicing them slowly and deliberately and repeatedly, working through mistakes until improvements are solidified. Have you ever noticed how, when learning a musical instrument or a new sport, starting slowly and focusing on technique can make all the difference? One key insight from this work is the role of myelin, a fatty substance that surrounds nerve fibers in skill development. When you engage in deep practice, you strengthen the neural pathways associated with that skill. This process of myelination essentially makes your brain more efficient, allowing you to perform tasks faster and with greater accuracy over time. For example, imagine a student learning to solve math problems. By focusing on understanding each step and correcting errors as they occur, the student gradually builds a more robust network of skills that eventually leads to mastery. Deep practice also emphasizes the importance of pushing yourself just beyond your current abilities. It's not enough to simply repeat a task. You need to challenge yourself by working through difficulties and making mistakes, because these are the moments where real learning happens. Have you ever found that the most challenging part of learning something is also the part where you grow the most? That's the essence of deep practice. It's about stretching your limits and gradually expanding your skill set. Another aspect of the talent code is the idea of breaking skills down into smaller, more manageable chunks. When you practice these chunks individually, you can fine-tune each part before integrating them into a whole. This method not only builds confidence, but also leads to more consistent performance. Think about a dancer learning a complicated routine. By mastering individual steps and then gradually putting them together, the dancer can eventually perform the entire routine flawlessly. In summary, the talent code shows that extraordinary skills are built through a combination of deliberate, focused practice and the brain's natural ability to adapt and improve. This process of deep practice, supported by the science of myelination and the breaking down of complex tasks, can transform any learner from a beginner into an expert over time. What skill are you most interested in mastering, and how might you apply the principles of deep practice to get there? Deep practice refers to a focused, intentional, and often challenging mode of practice that goes beyond rote repetition. It involves breaking down complex skills into smaller parts, working on each component with concentrated effort, and gradually integrating them into a seamless performance. Research shows that this type of practice leads to significant changes in brain structure, such as the strengthening of neural pathways. The process is not merely about time spent, but about the quality of the practice sessions. A student learning to play the piano might slow down difficult passages, practice them repeatedly with attention to detail, and then gradually increase the speed as mastery improves. It's like constructing a building brick by brick. With each carefully placed brick or practice session, the structure is more stronger and more resilient. Deep practice is believed to work by increasing the production of myelin, a fatty substance that wraps around nerve fibers and speeds up electrical signals in the brain. As you repeatedly practice a skill in a focused way, more myelin forms around the relevant neural circuits, making the execution of that skill faster and more efficient. This process is akin to upgrading the wiring in your brain to boost performance. Over time, this neurological adaptation is key to developing expertise in any area. When a student practices solving math problems step by step, the neural pathways involved become more insulated with myelin, leading to quicker problem-solving skills during tests. It's like adding insulation to electrical wires in your home. The better the insulation, the faster and more efficiently the electricity or neural signals can travel. Deep practice involves not only repetition, but also actively identifying and correcting errors along the way. This process of making mistakes, receiving feedback, and adjusting your technique is crucial for learning and refining complex skills. Each error provides valuable information about what needs improvement, and addressing them reinforces correct neural pathways. Through deliberate error correction, you build a robust foundation for long-term math. A young athlete might review video footage of their performance to identify mistakes in technique, then work on specific drills to correct those errors. It's like editing a rough draft of an essay. Each revision brings you closer to a polished final version, ensuring your work is clear and effective. Deep practice often involves breaking a complex skill into smaller, manageable chunks that can be practiced independently. By mastering each segment individually, you can gradually integrate them into a cohesive whole. This incremental approach minimizes overwhelm and allows for focused improvement on areas that need the most attention. Over time, the chunks merge to form an extraordinary, well-honed skill. A student learning a new language might first focus on vocabulary and pronunciation before gradually integrating grammar and conversation skills. It's like assembling a puzzle piece by piece. By fitting small sections together, you eventually see the full picture. Deep practice requires intense, focused attention where distractions are minimized and every moment is dedicated to learning. This high level of concentration engages the brain's executive functions, leading to better retention and more efficient learning. Neuroscientific studies show that focused attention strengthens the connections between neurons associated with the practiced skill. Maintaining this focus over time results in measurable improvements in performance. A student preparing for a science exam might turn off all digital distractions and focus solely on understanding key concepts, leading to higher retention and application of the material. It's like using a magnifying glass to focus sunlight. The concentrated energy produces a powerful effect, much like focused attention enhances learning. Deep practice is intertwined with the idea of a growth mindset, the belief that abilities can be developed through hard work and perseverance. Students who embrace challenges and see mistakes as opportunities to learn are more likely to engage in deep practice. This mindset encourages persistence even when progress seems slow, leading to greater long-term gains. The scientific community has shown that consistent, effortful practice changes both the brain and behavior, reinforcing the growth mindset. A student who struggles with geometry but persists through deliberate, focused practice gradually improves, eventually excelling in the subject. It's like nurturing a garden. Regular care and attention help even a small seed grow into a strong, flourishing plant over time. Effective deep practice is supported by immediate and accurate feedback, which informs you about what's working and what isn't. Feedback can come from self-assessment, teachers, coaches, or digital tools, and is essential for correcting mistakes quickly. This process helps recalibrate your approach and reinforces the learning of correct techniques. Consistent feedback accelerates the refinement of skills and the formation of expert habits. A student might use an online math platform that provides instant feedback on problem-solving attempts, allowing them to adjust and improve continuously. It's like having a GPS in your car. It immediately tells you if you're off track, so you can quickly correct your direction and reach your destination more efficiently. Deep practice is a universal principle that applies to a wide range of skills, from sports and music to academics and creative endeavors. Although the techniques may vary by discipline, the core idea remains the same. Focused, deliberate practice builds exceptional ability over time. In every field, breaking down complex tasks, practicing with attention, and seeking regular feedback lead to superior performance. This concept is supported by extensive research in neuroscience and education, showing that the brain is remarkably adaptable when challenged appropriately. A young violinist improves their performance by isolating difficult passages and practicing them repeatedly, just as a student improves in math by tackling challenging problems one step at a time. It's like training for a marathon, whether you're running, playing an instrument, or solving equations. The same steady, focused effort leads to remarkable improvement. The cumulative effect of deep practice over time results in extraordinary skill development that goes beyond natural talent. Research shows that what we often perceive as innate ability is largely the result of sustained, focused practice and deliberate learning strategies. This long-term commitment reshapes the brain's structure, reinforcing neural circuits associated with expertise Ultimately, deep practice transforms a novice into an expert by creating lasting changes in both behavior and brain function. An individual who dedicates years to practicing chess with deliberate focus eventually reaches a level of mastery that seems almost extraordinary compared to casual players. It's like constructing a building. Each day's effort adds another brick, and over time, these bricks form a robust, impressive structure that stands the test of time.